Any problem on handling code, first write this table. So finally, what are the bits that we will be using as correcting bits? C1, C2, C3, right? So assuming that we are having 4 messes and then 3 parity bits, we have totally 8 cases. So we are having 3 parity bits, right? So 8 positions we have to verify, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Once you write this, you will get a clue about what are the parity bits, which parity bits are checking what. Now if you see C3, one group is 1, 3, 5, 7. So from this you can understand that the parity bit at position number 1 is supposed to take care of the message bits 3, 5 and 7. And similarly, if you look at this C2, it is going to give you 2, 3, 6, 7. So what does it mean? The parity bit present at 2, position number 2 is going to take care of 3, 6 and 7 message bits. And if you look at this C1, it is going to give you the class 4, 5, 6, 7. What does it mean? The parity bit at position number 4 is going to take care of 5, 6, 7 message bits, right? Okay, now let's take an example. Let us say we are supposed to send a message of maybe it is not BCD 1100, something like this. This message has to be sent. Now how are you going to send it? So we are going to have 1, 2, 3, 4, 5, 6, 7 and the message is going to be placed in its appropriate position. This and this are going to be left for parity and the message is going to be placed here 1100. This is the message, right? And the receiver knows that the message will be present here after correction. Don't worry about it. Receiver already knows the rules. Now look at what should be happening. What should be the value of the parity at position number 1? It is supposed to take care of 3, 5 and 7. 3, 5 and 7. Even number of ones are there. Therefore, you need not add any 1. So it is 0. And look at position number 2. It is supposed to take care of 3, 6 and 7. 3, 6 and 7. Odd number of ones are there. So you are supposed to add 1. So parity at position number 4 has to take care of 5, 6 and 7. So 5, 6 and 7 odd number of ones, therefore we have to add 1. Got it? So this is the message which will be transmitted. So this is the message which is going to get transmitted. Now let us say this particular bit has got corrupted during transmission and the receiver has got the message 0, 1, 0, 1, 1, 0, 0, which means instead of 1 here it got 0, right? Now let's see how will the receiver correct it. Now receiver has to correct it depending on various factors. So receiver will do this. See this. Now receiver has to check what are C1, C2, C3. What is C1, what is C2, what is C3. Now C3 has to take care of 1, 3, 5, 7. Therefore 1, 3, 5, 7. It will check if the parity is even, but the parity turned out to be odd. Therefore it says that I found out an error. What about C2? C2 is supposed to check 2, 3, 6, 7. 2, 3, 6, 7. It also says that I got an error because it got 2, 3, 6, 7 is odd number of ones. It says that I got an error, right? Now what is C1 supposed to do? C1 is supposed to check for 4, 5, 6, 7. 4, 5, 6, 7 even number of ones. So it says that I have not seen any error. Therefore error turned out to be 3. How is this possible? The third position is error because 0, 1, 1 is third position. So it will correct it to 1 and then it will take out the message. What is the message? Message is present at 3, 5, 6, 7. This already receiver knows. Therefore it will understand that message sent is this and the remaining 3 bits will be ignored, right? So now how does this method works? See this. C2 and C3 are saying that there is an error, which means the intersection of C2 and C3 is going to contain error. What are intersection? 3 and 7. Got it? And now C1 is saying that I don't find any error, which means from this you have to subtract this, which means 7 will get cancelled out. Therefore only remaining case is 3. That is how it works, right? Now I think you understood this. So let us say instead of sending 4 bits, what if we have to send 5 bits? If the data size is 5 instead of 4, then it should add how many parity bits we should add in the beginning. So if the data size is 5 instead of 4, how many parity bits should we add? Let us say the number of parity bits is p, then 2 power p should be greater than or equal to, now I am assuming that the data bits are 5. 5 plus p plus 1, what does it mean? That implies 2 power p should be greater than or equal to 6 plus p, right? Now you find out the value of p in such a way that it satisfies this equation. If you go with p equal to 3, this side we get 8 and this side we get 9. So 8 is greater than or equal to 9 is false. And therefore we have to go with 4. If I go with 4, this side I get 16 and this side I get 10. Therefore, what does it mean? I have to go with p equal to 4 in order to satisfy this. But if I go with p equal to 4, how many combinations do I get? 16 combinations. But then how many cases we have? Totally we are sending 5 plus 4 bits, 5 message bits plus 4 parity bits. Therefore totally we are sending 9 bits. So the total number of cases will be 10, because an error can occur in any one of these 9 and no error can occur. Therefore total error combination or total cases we have to handle is 10, but the total combinations we got is 16, which means we are not going to use 6 combinations at all. So just let's see what are the errors that can happen here. See, now instead of this C1, C2, C3 like this, 3 bits are not enough because we have to handle 10 cases, right? So I am going to have 4 correction bits, C1, C2, C3, C4 and 4 parity bits, right? So I have to extend it 0, 0, 0, 0, 0, 0, 0. What does it mean? From 0 to 7, which means 7 bits can be wrong, as well as we can have an error even in the 10th position also, right? Which means we can have an error at the 8th position, we can have an error at the 9th position, as well as we can have an error at the 10th position. From 11 to 15 we need not use them, right? Therefore we have to have all these. Okay, 9th, we don't have even 10th position also, because we are sending 5 plus 4 9 bits. So any one of these bits, 9 bits can get corrupted or there can be no corruption. This is 1, this is 0, which means it indicates that no error has occurred. It indicates that error is at position number 1, position number 2, position number 3, 4, 5, 6, 7, 8, 9. That's it. You need not go beyond it. Error cannot be at position number 10 because we don't have those many. But then with 4 bits we can get 16 combinations, but we don't use them. That is okay, right? And now let's take an example and I'll show you how this one works. So before going to the example, let's see what each one of the groups is supposed to take care of. So C4 is representing 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. What does it mean? The parity bit at position number 1 is supposed to take care of the message bits at 3, 5, 7 and 9. And then C3 is going to take care of 2, 3, right? And then 6, 7, that's it. So what does it mean? The parity bit at position number 2 is supposed to take care of the message bits 3, 6 and 7. Now let's see C2. C2 is going to take care of 4, 5, 6, 7. 4, 5, 6, 7. What does it mean? The parity bit at position number 4 is going to take care of message bits at 5, 6 and 7, which means the entire group put together is going to have even parity. And now what about C1? C1 is going to have only 8 and 9. So what does it mean? The parity bit at position number 8 is going to take care of message bit at position number 9, which means these two bits put together should produce a even parity. That is how we are supposed to fill out the parity bits. Now how many bits are we sending? So let us say the message that we have to send is 5 bits, which is 11011, something like this. Okay, and now how many positions we are going to have? We are going to send 5 bits plus 4 parity bits. So totally we are going to send 9 bits. 5 bits, 5 message bits and 4 parity bits. So totally we are going to send 9 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9 bits. Okay. And in this we are going to put parity bits at the powers of 2, 2 power 0, 2 power 1, 2 power 2, 2 power 3, and in the remaining places you just write the message bits. So message bit is 1 1 0 1 1, right? And now if you observe it, C4 1 3 5 7 9. So 3 5 7 9, they are having 4 ones, therefore it is going to be 0. 4 ones is even, and 2 is going to take care of 3 6 7, 3 6 and 7, even number of ones, therefore 0. And 4 is going to take care of 5 6 and 7, 5 6 and 7, even number of ones, therefore it is 0. And 8 is going to take care of 9, so only 1 1 is there, therefore 1. Got it? So this is the message that will be transmitted, even though the message that that you wanted to transmit is this one. Got it? Now let us say during the transmission one of the bit got corrupted. This bit got corrupted and it got changed to 0. So let us say the message that the receiver has received is 0 0 1 0 1 0 0 1 1. Instead of 1 here it received 0. Now it is supposed to correct it. Let's see how the correction happens. For that, just number them 1 2 3 4 5 6 7 8 9. Find out C1 C2 C3 C4. Now how to find out C1? C1 is going to take care of 8 and 9, right? Therefore 8 and 9 is nothing but even parity, it is still there, therefore no error. Now C2 is going to take care of 4 5 6 7. Now check this, 4 5 6 7, it has got odd number of ones, therefore there is an error, so C1 is 1. And now C3 is going to take care of 2 3 6 7, 2 3 6 7. So 2 3 6 7 has got odd number of ones, therefore it has detected an error, C1 equal to 1. And what about C4? C4 is going to take care of 1 3 5 7 9, 1 3 5 7 9, odd number of ones, therefore it has detected an error, so 1. Now what is the error? Error is at 0 1 1 1 position, which is nothing but 7. Got it? So how did we get it? C2 C4 and C2 C3 and C4 are saying that we detected an error, which means an error has to be in the intersection of all these three. So if you watch them, the intersection of all these three is 1 is not present in all three, 2 is not present in all three, 3 is not present in all three, 5 is not present in all three, 7 is present in all three. So if we take the intersection of this, we got 7. So directly we can say that in not even go for C1 also, we can say that 7 is the error. Got it? So this is how we can solve them. So what are the questions that they might ask is, they will give you the message and they'll ask you what is the message after Hamming codes are added. That is one kind of question. Second question is, they'll give you the message and they'll ask you find out the error if any. So you are supposed to do this and find out the error. Third thing is, they will say that the number of bits in the message is m, then how many parity bits are you going to use? For example, they'll say we are sending a message with FCD code with 8 bits. So message size is 8 bits. Then how many bits of parity are you going to add? Then you substitute there. 2 power p has to be greater than or equal to 8 plus p plus 1. So what does it mean? 2 power p has to be greater than or equal to p plus 9. Now substitute p equal to 4. Here I get 16, here I get 13. Therefore 4 bits are sufficient, isn't it? Here I get 16 and here I get 13. Therefore 4 bits are sufficient. Why? If we add 4 bits to 8 bits, the total combinations are going to be 12 plus 1. So 13 combinations you have to handle, and we have 16 combinations. 13 cases we have to handle and we have 16 combinations. It is perfect. Got it? So likewise, they will give you the message size and they will ask you to find out the number of parity bits that have to be added, or they will ask you some question like this. Okay, anyway you can solve it. It is easy.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So First reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.